Okay, we're going to do 7.4, which is solving these log equations. We have rewritten a logarithm as an exponential and vice versa using that definition, and we've been evaluating logarithms often by using the definition. So let's remind ourselves of the definition. Okay, y'all seem to have that pretty down pat. So how can we use this to help us solve an equation? And in our first example, I have log of a certain base, let's call it 9, I have an x is equal to 3/2. And I want to solve this for x. So I'm going to use the if and only if definition to say 9 raised to the 3/2 is equal to x. And of course I can figure that out because that's a square root of 9, and then I cube it. Notice how I decided to do the square root first to make my life a lot easier. Square root of 9 is 3, 3 cubed is 27, and that gives me x. So we might try one other example where we change positions up a little bit with where the x is. What if we had log base x? We don't know what the base is. Of 4 is equal to a -2. And how would you solve this? Well, there's a single logarithm. I'm going to use my definition to write it as an exponential. So the base raised to the answer of a logarithm, so that becomes an exponent, would equal to that 4. Okay, so remember what a negative exponent means. That's 1 over x squared. I could solve this. 1 is equal to 4x squared. I could square root both sides. So 1 is equal to, and I'm actually going to put a plus or a minus on that, 2x, right? And I think I have two solutions. But we only allow the positive bases, so in this case x will equal positive 1/2. That's your base. Here's a u-try for you. Log base 16 of x is equal to 5/2, and pause it because I'm going to be putting the answer up real quick. Okay, here's another type of logarithmic equation that's different than before. You'll notice it's different because it has two logarithms. But what's interesting is it only has two logarithms as well, okay? So that's important to us because in this case we can use something we're familiar with and we like very much. We're going to use the one-to-one property. We talked about this before, definitely with exponentials. And we can do the same thing with logarithms. If you have the same bases and a log on both sides, then that can only be true. So let's say then if x is equal to y. So it's really a if and only if as well. So this can go both ways, and we actually will be able to use this both ways. So same idea, but make sure you are using same bases. Okay, that's important. Alright, so how would you solve this one? Quite easily then with our one-to-one property. They both have log base 3, so x squared minus 15, this sort of argument it's called on the left, that kind of taking the place of the independent variable, is 2x on the right. So lo and behold, I have found myself with a quadratic equation. So this kind of tripped up more than one of you on the last test, where you found yourself with a quadratic equation, and they're just going to keep popping up all over the place now because we do know how to solve these. I'm going to try and factor it. If it didn't factor, I would have to use quadratic formula, but let me try. 3 and 5 minus plus, aha. Then there's that zero product property. I have the 0 on one side. It allows me to solve this one and this one because that's a product, so one or the other has to equal 0, or both. Okay, so that's a solution using one-to-one property, which really just boiled down to solving a quadratic in this case. Before we go on, we better mention one more important fact, checking domains. Now, this whole idea of having the quadratic and two equations came up. I almost got distracted. Domain. We want to be able to check our domain. If you remember, what is the domain for a log function, just like the parent function? And if you need to, you can think about the graph to help you with domain. Remember that graph? And we had that x equals 0 asymptote, and the thing came up the asymptote and kind of flattened over. So when you look at this and you say the domain, okay, that domain then would be x is greater than 0. It's not ever going to equal 0, but the domain for a logarithm, parent function, y equal log any base x, that domain would be x is greater than 0. So whatever that argument is, has to be greater than 0. So it's possible that these fit in the domain, but we should check. So the -3 squared minus 15. And the question is it greater than 0? And the answer would be no. So this one is not in the domain. That is what you call an extraneous solution. Okay? You would not be able to take the logarithm using that x value. Okay? So it's very important that we check the domains. You always take logarithms of greater than 0.